So we're talking about perimeter and area by definition. And if you are taking notes, I suggest you get yourself a piece of notebook paper, put a line right down the center, because we are going to compare and contrast perimeter and area today. So I'm going to put perimeter on this side, got area going here. Let's look at them. So let's just start with what they mean. Have you guys heard these terms before? Do you know what perimeter means, Josie?
Yes.
Yeah, you've heard of this word before. How would you describe it if I asked you?
Is the outside of the shape.
I hear a lot of people say the outside. Yeah, that's a pretty good summation of it. Peri means to go around and meter means to measure. So yeah, perimeter is to measure around the outside of a shape. The technical math definition is the continuous, so you should know there's no break in it, line forming the boundary of a closed geometric shape. Now we're really using math speech now, but does that make sense to you?
Yes.
Wonderful. Now let's contrast that with the concept of area. Now, a lot of students, when I ask them, what does area mean? They tell me area means the inside. I actually would ask you to just throw out that definition if that's the one you've memorized, because students who memorize it that way mix up area and volume. Because I guess it's kind of two different ways to think about the inside. But the area is the, I don't have the breakdown of it like I did for the other one, but the definition of it is the extent or measurement of a surface. So better than saying inside, probably a nice quick way to think about this is it's a covering. So it covers a surface. Does that make sense?
Yes.
Okay, wonderful. So let's then think about this. We had said that perimeter is a continuous line. So if you think about, let's just start with the simplest shape we have in geometry, probably our rectangle. And if we want to talk about the continuous line that goes around the outside of a rectangle, drawn a picture of it there, it's bent, but it's still just a line. This is what we call a linear measurement. Linear meaning it's a line. We're measuring a line, okay? It might be a crooked line, a bent line, but it's still nonetheless a line that we're measuring. Therefore, it is just a one-dimensional measurement. Does that make sense?
Yes.
Wonderful. Now let's contrast that to area. Area, I don't want to go around my rectangle. Instead, I want to cover it. And so I'm looking to cover, I'm going to have to come out in 2 dimensions. And this is not a linear measurement. This is instead a square measurement. It is a square measurement. It is 2-dimensional. You would not be able to just cover your shape with lines, you know, depending on how thin your lines were, you'd be working all day. Instead, we cover with squares. Does that make sense?
Yes.
Okay, wonderful. So I bet because you have some background knowledge of this concept, Josie, this is going to be pretty simple for you. But let's try to, without using any formulas or any math definitions, let's try to think about how we would find the perimeter of a rectangle that was, say, 3 inches by 4 inches. Now, I have a whole lot of students who tell me, Kate, I know perimeter. My math teacher taught me perimeter. To do perimeter, you just add. And then what they'll do is they'll do a very common misconception, and they'll just add 3 plus 4.
Yeah.
But going back to the definition of perimeter, we said that it was a continuous line forming the boundary of a closed geometric shape. And I'm sure that you can see, Josie, that if I just added 3 and 4, I would not be closing my rectangle. It's still open. I need to go all the way around, get that total length all the way around. So I bet you could tell me how to do it, huh? How would I find the perimeter of this shape? Any ideas?
You would have to do 3 plus 3 plus 4 plus 4.
Absolutely. So, and I'm going to do it in a different order, not because your order was wrong, but just because I think it's easier to think about it first. I'll add the 3 and the 4, but then I'll keep going around the shape. I'll add this side here, which obviously, as Josie saw, is going to be the same as the side across from it. So it will also be 3. and this side here, which will be on a rectangle, the same as the side across from it, so also 4. So yes, hopefully we can see that the shortcut, easy, simple way to find perimeter is just to add up all the sides, because all I'm looking for is the total length of that line. Okay, nice and sensible. Now let's think about area. Again, it's always hard to backtrack if you've already memorized this, but let's pretend like we know nothing about area. We wanted to look at the number of squares to cover a shape. So let's, again, imagine that we've been asked this time to find the area, but that we still have a 3-inch by 4-inch rectangle. So now this time, instead of just going around the outside, I want to cover the entire shape. So I have this 3-inch division. I'm going to just extend these markings out to cover it lengthwise. And now I've broken that into 3 rows. Same thing here, I've got 4 inches going across. So I've divided this into 4 pieces now, and again, I'll extend my markings so that I can cover my shape. And now it's easy to see the number of squares that cover. I have 3 rows of 4 squares. I have a 3 by 4 array. And so I can just very simply multiply 3 times 4, and I would find out that I would have 12 squares. And how big are my squares? They're each an inch square, an inch by an inch. And so those are 12 square inches. Okay, and what did, I never did my math over here, did I? What did I end up with? 14 inches. So what did we do mathematically here? Since we ended up with all these nice rows with the same number of squares, we were able to multiply. We multiplied the 2 dimensions, which makes sense because I said that this was a 2-dimensional measurement. And so I would multiply the 2 dimensions together. Now, some students get really mad at me right now. Students who've been beyond this stage of math, who've worked with formulas, will tell me, Kate, that's not always true. When you're finding area, you don't always multiply the 2 dimensions. We're only doing that because that's a rectangle. And I would actually disagree with you. So we won't do it right now because we haven't introduced the formula sheet yet. But when we start looking at the formula sheet, I will prove to you that every single one of those area formulas have a multiplication of 2 dimensions as part of them. It might not be the only thing we're doing, but we always do that. Does that make sense?
Yes.
Okay. Great. Okay, I'm going to compare perimeter and area a few more ways, but I want to make sure you have these notes. Are you good with everything we've got here?
Yeah.
Great. Oh, hey, Marley, I didn't see you join us. Hi. Okay, so let's clear this page, and let's keep on comparing perimeter and area. Now, one thing you may have noticed in the 2 problems I just worked is that I wrote the answers differently. I wrote the unit of the answer differently. When I wrote perimeter, I said that I had 14 inches. And when I had area, I didn't say inches, I said square inches. Now I was too lazy to spell that out, but I'll spell that out for you here. This is regular plain old inches. This is square inches. And this should make sense to us if we understand what we were talking about earlier. We were saying that perimeter was measured, it's a line. So it's measured in a linear measurement, like an inch is just a little line. But area we're covering with squares. So when I talk about a square inch, what does that mean? It means a square that's 1 inch tall by 1 inch wide. Okay, and we're always going to find that. We're going to find that perimeter is always measured in linear units. Even if they're not inches, it will be some kind of linear unit of distance. And area is always measured in square units. So let's think of some linear units of distance first. We know about inches. What other ways can we measure distance? Anybody know?
Feet.
Feet, sure. Anything else?
Centimeters.
Centimeters, great. We have the metric system. How about if I was going a far distance?
Yards.
I could use yards. How about if I was driving?
Miles.
Miles, exactly. Or meters or kilometers. Any of those are linear units of distance. Now, how do we get from that to a square unit? Literally, all we do is throw a little 2 on there. Mathematicians are too lazy to spell the word square. We're not telling you to do extra math. We're just literally being too lazy to spell out square inches, square feet. Notice I'm not saying feet squared, I'm saying square feet. Square centimeters, square yards, etc. So it's those same distance units, but they'll be squared. Is everybody good with that?
Yes.
Okay, great. We're almost done with this concept. We're going to try some practice problems. But before we launch into the practice problems, my warning to you ladies is that the GED won't tell you that it's a perimeter problem or an area problem. Most likely this will be hidden in a word problem. You will be expected to read the word problem and to just know if this is a perimeter or if this is an area problem. And quite often it's buried in a 3-step, 4-step, 5-step problem, and you all get lost. Okay, so let's look at some clear-cut ways in the real world when perimeter and area comes up. Okay, so I want to imagine that we went out to the backyard. Let's go out to the backyard. There is a perimeter around our backyard. There is an area over our backyard, covering our backyard. So you tell me, what item might I have around my backyard?
A fence.
Sure, I could have a fence. I could have a wall. I don't know. I could have chicken wire, all kinds of things. I could even have a line of trees around the outside of my backyard, but it would be going around the outside. Wonderful. I have students all the time where I ask them to find the fence and then they multiply, find area for me. And I'm like, did you just cover your backyard in fence? How stupid would that look if our entire backyard was covered in fence? That would be pretty silly. Okay, so then, but what does cover our backyard?
Grass.
Grass. You're imagining that we live someplace besides Arizona, aren't you? It would be so nice if we had grass. We probably have rocks, but yeah, we can imagine a better world together, Josie. Grass. Okay, so let's go somewhere else. Let's go to the window in your living room. I want you to face the window with me. Think about the perimeter of the window. What might we find around the outside of a window?
Window? Or I don't know. What is that? The trimming?
Yeah, the trim. Sure, window trim. We might call it the frame. I had one problem that I saw on a GED practice test that stumped all the students. It was about weather stripping. They said, I never heard of weather stripping in my life. I said, yeah, but would you think you'd put weather stripping around the window or over the window? Probably I'm not going to put anything over the window or I won't be able to see out, you know? So then let's think about that area. If I want to cover the window, what might I cover the window with?
Glass.
Glass. Sure. Sometimes we cover our window with curtains.
Okay.
And that'd be a good covering. Okay, great. There was one about painting the living room. I'm painting the living room, and they wanted to know how much paint to use. You think I'm measuring perimeter, or you think I'm measuring area? Oh, Josie got distracted.
Perimeter.
Perimeter. So if I'm doing perimeter, that means I'm just going to paint one thin little line of paint around the outside of. I think your house might look a little silly if you just put paint here, 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 and here. You probably would take the entire wall and cover it in paint. Does that make sense?
Yeah.
So anytime you want to cover, you're going to want to go with area. And poor Miss really stepped in late, so she's at a disadvantage right now. Another one that commonly comes up, a Ferris wheel. There's a problem that everyone, I do not know it because I have not taken the GED, but I have to tell you that students all over the internet are freaking out about the Ferris wheel problem. The Ferris wheel, how do you do a Ferris wheel problem? And I'm like, depends on what it says. What are we measuring on the Ferris wheel? You know, okay, so we could talk about how far the riders travel. So if I'm talking about how far the riders travel on a Ferris wheel, well, would the riders travel around the outside of the Ferris wheel, or would the riders cover a Ferris wheel? You tell me, how does a rider travel? Anybody?
In circles.
In a circle, exactly. So we're talking about going around the outside, so that would be more a perimeter problem, and we'll find that there's a special name for the outside of a circle, which is known as circumference, but we'll do that a little later. But just it is a type of perimeter problem, so we're going to leave that here as if we were traveling on a Ferris wheel. Okay, so a lot of things they could ask you. Another problem that I saw in the GED before, or GED practice examples, walking around the block. Someone took a walk around the block. So again, when we walk around the block, do we walk around the outside of the block, or do we cover the block with our footsteps?
Around.
Yeah, exactly, around. And so even though it will not say it, that would be a perimeter problem. Okay, we got the idea, ladies. We're ready to start the real GED style problems?
Yeah.
Okay.
Yeah.
Okay, first thing I want to do, now you might be brilliant mathematicians, I hope that you are. You might be able to look at problems like this and know exactly what to do. That's not exactly where I want to focus. I want proof today of why you would do what you would do. So let's look at problem number 1. It says, Lizette plans to carpet his living room. Well, that's an interesting name for a man. Sounds like I made a typo. If the room is 18 feet by 12 feet, how many square feet of carpeting will he need? Okay, my first question for you, area or perimeter?
Area.
We have some votes for area. If you vote area, I want proof. What in this problem tells you it's an area problem?
It says square feet.
Oh, good. It says a square unit. Anytime they ask you for a square unit, that's a really big clue that you're looking for area. In fact, make a note to yourself, the only thing measured in square units is area. Could be surface area, but just area is the only thing measured in square units. So really big clue, I'm looking for area. But that's not the only thing. Anything else in this problem tell you that we're looking at an area problem? Like, no, what does she want? Here's the other thing I notice. It is carpeting. I would love for you to just imagine how absolutely ridiculous your house would look if you only put the carpet around the outside edge of the living room. We don't do that, right? We cover the entire floor with carpeting. And so clearly that's an area problem. Okay, so we said if we have a rectangle, and we can assume the room is rectangular because it didn't specify otherwise, that's 12 feet squares this way by 18 little squares that way. What we're going to end up with is 12 rows of 18. We are going to multiply for area. And I had a student who made a little X to cover the shape so she could remember. And I thought that was good. So 12 feet by 18 feet. Can you guys hear my coworker speaking Spanish in the background? I love sharing an office. Okay, so I'm going to do the work in my calculator. No, I'm not, because I lost my calculator. I have to do it in my head. No, I'll do it on the side. Anyway, if you did this on the GED, you would have a calculator. Okay, 216. So I get 216. Now, ladies, I really want to stress to you, just a number is not an answer in geometry. I have to know 216 what. So I just found the area. So it should be 216 square feet. Now, you could write out the word square feet, but I'm way too lazy. So I'll use the abbreviation for feet and throw a little 2 on there to tell you that it's square feet. Is that good? Okay. Let's look at number 3. Jeanette wants to fence in her pool so the neighborhood children cannot fall in. If the pool area is 22 feet by 25 feet, how many feet of fencing will she need? Now, I really like this problem because students see this right here and they go, hey, look, a time sign. And they just start timesing away very happily. Yeah, Josie's like, they were tricked. Okay, and if you do that, you were tricked. So be careful. A time sign doesn't necessarily mean do an area problem. It can mean the word by. It's a very common abbreviation for by. Yeah, be careful because the time sign is can mean just the word by. It doesn't necessarily mean to multiply. So you guys tell me, area problem or perimeter problem? Oh, perimeter, you say. Give me proof. What in this problem tells you that it's a perimeter problem?
Is that she wants the fence.
Brilliant. Josie says it's the fence that tips me off. It would look pretty stupid if you covered your entire pool with fence. No one would be able to swim. Yeah, we're going to go around the pool with a fence. One more bit of proof in this problem that I'm looking for perimeter and not area. Anybody see it?
It says the pool area. So which means you would have.
It says what? It does say pool area, so it even feels like an area problem, but it's not an area problem. I've got one more piece of proof that it's not an area problem. It's the unit. Go looking for the unit they asked me to find. What did they ask me to find? How many feet? They didn't say how many square feet. They said plain old linear feet. So plain old linear feet, another big clue that it's perimeter. Does that make sense?
Mm-hmm. Yeah.
Good. And now, and so students, you know, my students who just try to memorize this by force. See that word area, see that time sign, don't even pay attention to the rest of the problem and get it wrong. Okay, so I'm looking to do perimeter. I have an area that's 22 feet by 25 feet. Now I have to tell you the next place students go wrong. We already talked about this a little bit at the beginning, but students just go, perimeter, I'll add. Yeah, we do add for perimeter, but what did the foolish student, what's wrong with this work right here if I just add 22 and 25?
You're missing half of the problem.
Yeah, you're missing half the fence. Hello, if you only put a fence on two sides, the kids are still gonna fall in. You better keep going. We need this side, so we need another 22 feet of fencing, and we need this side, another 25 feet of fencing. Okay, sweet. Does that make sense to everybody?
Yeah.
Okay, so let's see if I can do this in my head. 94? 25 and 25 is 50? Yeah. Okay, so 94 what? 94 square feet or 94 plain old regular linear feet?
Feet.
Exactly. We're just measuring the line of fence. Plain old regular feet. There we go. We good with that?
Yeah.
Okay. Now this is what I wanted to do because I feel sorry for all the students who didn't grow up in the 80s because they don't understand this problem. But all the test writers did grow up in the 80s. So let's go ahead and do this. We used to have border in our living rooms. Okay. Y'all can't even envision the hideousness that was the 80s borders in the living rooms. But let's take a look at this problem. Number 4. It says Todd wants to put a border around his living room. Okay. Todd's living in 1982. If the room is 17 feet by 14 feet, how many feet of border should he buy? So once again, ladies, I would ask you, area or perimeter problem?
Perimeter.
I have an argument for perimeter. Give me proof. What makes you think perimeter?
Feet.
How many feet of border? Absolutely. That's a good proof.
Around.
Exactly. Borders go around. Exactly. So we don't cover the entire wall with border. It was just this line that went around your living room. Okay. And so this is a perimeter problem, even though a lot of students mistake it for an area problem. So we will, again, make sure, that when we do the perimeter of the square, we cover all our walls. We're not just going to put a border there and a border there. We're going to get to the third wall and the fourth wall. We're going to add all the sides, not just to the 2 dimensions. Okay, good. So let's see, 14 and 17 would be 31. So we're looking at 62. 62. And square feet or linear feet?
Feet.
Regular, plain old linear feet. Good. Okay, ladies, super simple?
Yeah.
I wish that it were that simple on the GED, but I got to be honest with you, guess what? There's not really many one-step word problems. Sorry. It's just the nature of the beast. They like 2, 3, 4-step word problems to test if you can handle different skills at once, if you know more than one math concept. Let's go ahead and look at some multi-step area and perimeter problems. Okay. So Tiny House Inc. manufactures homes with just 3 rooms. One room is 14 feet by 11 feet. Another is 12 feet by 10 feet. And the last is 6 feet by 6 feet. How many square feet is the house? So yeah, it's a multi-step problem, but still the basic concept here is area or perimeter. So you guys tell me, area or perimeter?
Area.
Josie says, area, can you give me some proof?
It says square feet.
How many square feet is the house? Yes. And in fact, we almost always measure the size of houses in area. I have never, how big is your house? You're going to tell me the square feet. Okay, does that make sense?
Yes.
Yeah, because we're talking about living space, not the line around your house. Okay, great. So, but I've got some planning to do on this problem because there's not just one room. Okay, we've got 3 rooms to consider. A 14 foot by 11 foot room, a 12 by 10, and a 6 by 6. And I cannot tell you how many students just multiply these 6 numbers together. Because they just kind of go, area means multiply, and here's 6 dimensions. That's small. If you multiply all 6 together, you are giving me a 6-dimensional shape. I can't even imagine, how would I have 6? You can't, okay, we multiply when we have dimensions, okay, but these are all two-dimensional shapes. They're all square feet. So each one we're going to need to treat separately. We have a 14 by 11 room. We'll find out how many square feet he is. So what is that, 154?
Yeah, 154.
We have a 12-foot by 10-foot room. And I'm looking for the square footage of this room, so I'll multiply these two dimensions together. So I get 120 square foot room. And of course, my 6 by 6 will be 36 square feet. But I'm not just looking for the individual rooms. I'm looking at the total of the house. So how could I total these three numbers together, guys?
You could add them.
Absolutely. If you just want to total up a list of numbers that are not the same, you just go ahead and add. And so then students get mad at me. They say, why are you adding when it's not a perimeter problem? I said, because I'm trying to find a total of something. Okay. So, yeah, Josie, do you have a calculator in front of you since I lost mine?
Yeah, it's 310.
Yeah, that sounds right. So 310. And 310 what? Well, if I had square feet and square feet and square feet, I still have square feet. A certain company charges $4.95 per square foot to lay patio. How much would they charge to lay a 20-foot by 12-foot patio? Once again, they didn't say the word area, they didn't say the word perimeter, but this is one of those kind of problems again. So anybody, is this an area problem or a perimeter problem?
Area.
We say area. Give me proof, please.
The patio, you wouldn't lay just...
The way you lay patio, absolutely. You wouldn't just lay patio in a line around your backyard. That would look so silly. You would cover that whole area in patio. Any other proof?
The square foot.
Exactly. We're getting this charge. The $4.95 is not per foot, it's per square foot. So we're going to have to find the area before we can mess with the charges. So let's do it. If this side is 12 feet and this side is 20 feet, that means I will have 12 rows of 20 feet. Remember, when we're finding area, we're putting those squares out in rows, and so we're going to end up multiplying 12 by 20. And so I get 240 square feet. Then I have so many students who just stop right there. I found the area. I'm done. So proud of themselves. Yeah, let's finish this sucker up. They didn't, area was on our way to where we were going, but our final answer is supposed to be how much would they charge? So let's see. I've got 240 square feet of tile, and they're charging me for each one. That means for the first square foot, they're going to charge me $4.95. For the next square foot, they're going to charge me $4.95. They're going to keep doing that for every single square foot for 240 square feet. That means they're going to charge me $4.95 240 times. And so I'm going to multiply. Does that make sense, ladies?
Yeah.
Okay, wonderful. I really need your calculator now, Josie. Hook me up.
1,188.
1,188. Okay, so, and my final unit is in dollars, of course, because I was looking for the total charge. Okay, we're almost done. My coworkers will be so grateful. Okay, a certain company charges an installation fee of $1.75 per foot of fencing they install. How much would they charge to enclose a 200 foot by 250 foot property? So once again, I would ask you, is this area or perimeter?
Perimeter.
Brilliant. Thank you for not getting tricked. Give me some proof that this is a perimeter problem.
It's a fencing.
Fencing. Cool. More proof.
And to enclose.
Enclose. I love that word. Enclose means to go around. One more thing. Look at that charge. It's $1.75 per foot. Plain old linear feet. Great. So this is definitely a perimeter problem. So let's start with finding the perimeter of our property. So we have a 200 foot by 250 foot property. And we remember when we find perimeter, we're making a line all the way around the outside. So we'll add up all the sides. So I should see 4 numbers adding, not just the 2 dimensions. So 509, that looks like 900 feet of property. And then all the students go, oh, I found perimeter, I'm done. And they go home and go to sleep, but they shouldn't yet. Josie's shaking her head at me. No, of course not, because we were asked to find how much they would get charged. So again, it's 900 feet of fencing, but they're going to get charged $1.75 for their first foot, $1.75 for the second foot, and so on and so forth. They're going to get charged $1.75 900 times. So I'll times that by 900. Okay, you tell me, Josie, Josie of the calculator, what would I get?
1,575.
Beautiful. Expensive. I might not build that fence after all. $1,575. Beautiful. Why do I have number 8? Oh, I thought number 8 was a straightforward problem and I was about to get tricked. Let's see if it would trick you too. This is a nasty problem for a lot of students. Now, there's 2 different ways to work on it. So I'm going to divide this in half. And some students hate it when I teach 2 different ways, but the fact of the matter is half of you will think about it one way and half of you will think about it another way. So I got to do it both ways. So just completely ignore the one you don't like. Okay, here we go. A certain room is 21 feet by 18 feet. How many square yards of carpet would it take to carpet the room? So first of all, is it an area problem or a perimeter problem?
Area.
Area, I agree with you. Could I have some proof?
Square yards.
How many square yards? One more piece of proof.
And your carpeting.
Yeah, it's carpet. Yeah, if you put carpet around the room, you'd look like an idiot. We put it over the floor. Okay. So we're definitely finding area, but I want to take a look here. Take a look at your original units. Original units we were given is 21 feet by 18 feet, and then they want me to find square yards. Okay, so let's start with the simpler way to think about it, even if it's not necessarily the simpler way to do it. Okay, so my room is 18 feet by 21 feet. Now, these feet is not the kind of units I need. I need yards in order to get to square yards. So I'm just going to start with the linear measurements because most every student in the world knows how many linear feet are in a linear yard. Do you know, Josie, how many feet are in a yard?
3.
What was that?
3.
3, absolutely. There are 3 linear feet in a linear yard. And if any of you guys struggle with that, I always ask my students to picture those yardsticks. You know, the one your evil math teacher used to walk around beating against her hand. Those long yardsticks, you can imagine 3 rulers would fit really nicely on one of those long yardsticks because there's 3 feet in a yard. And so really nice if I know that these first 3 feet make 1 yard. And these next 3 feet make another yard. And these next 3 feet make another yard. In order to figure out how many yards there are in 18 feet, I'm going to have to break the feet into 3-foot sections. And so I'm going to divide. 18 divided by 3 feet in a yard would tell me that this same length is 6 yards long. Does that make sense? Mm-hmm. Okay.
Yeah.
Same thing for the 21 feet. The first 3 feet would make a yard. The next 3 feet would make a yard. I'm just dividing it into 3-foot sections when I break it into yards. And so I would find out that that's 7 yards across. Are we good with that? Mm-hmm. Now yeah. It would be super easy to go to how many square yards. If I'm 6 yards by 7 yards, 6 yards by 7 yards, I'm multiplying because it's area, will give me 42 square yards. Okay, is that cool with everybody? Now, yeah. I'm going to get out red because I want to show you the big mistake. This is how most students get fooled by this problem. This problem, if it showed up on the GED, would probably fool like about 95% of students because this is what they do. They don't notice the feet thing until the end. And so they go like this. They go, okay, it's 18 feet by 21 feet. They multiply 18 by 21. Now, there's nothing wrong with that. That's good math. That would find the area. So, Josie, what is 18 by 21? Hook me up in your calculator, please.
378.
And they tell me 378 square feet. And then they go back and read their problem and they go, oh, how many square? Darn it, it's supposed to be in square yards. And they divide by 3 right now. And this is the problem. They go, oh, there's 3 feet in a yard, and they divide by 3. Do that for me in your calculator. Divide 378 by 3.
126.
126. Did you get 42?
No.
It should match. Good math should match. How come it doesn't match? It doesn't match because it's not the same conversion for linear units that it is for square units. If you have all your linear units memorized, you do not know your squares. You do not know your squares. You know your linears. You know how many linear feet is in a linear yard. So I'm going to back up and take away the error here, which was dividing by 3. And we were just assuming that if there were 3 feet in a yard, there should be 3 square feet in a square yard. Let's check it out. So this is a square. Do you agree with me? That's a square. Okay, let's make it into a square yard. Okay, if it's a square yard, that means it's 1 yard this way by 1 yard that way. Okay, have I lost anyone yet? Does that make sense?
Mm-hmm.
Okay,
Yeah.
now I'm going to deal with each line at a time. Each line at a time. This line, I agree with you, is 3 feet. Okay, so that means I could break this into 3 divisions. But that's just one dimension. A square is a two-dimensional, so you have to consider the second dimension. This one would also be 3 feet, wouldn't it?
Mm-hmm.
So I could break this into 3 rows. 3 columns by 3 rows. 1 square yard is equal to how many square feet? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so your conversions will not work in square feet. You're gonna have to do some extra work to figure out the conversion unit, or you're gonna have to convert while you're still on the lines. Does that make sense?
Mm-hmm.
Okay,
Yeah.
so it's actually 9. So let's try dividing 378 by 9 and seeing if we get the same answer. Do that for me, Josie. What is 378 divided by 9?
42.
42. Good. Math always works. If you're doing something true, it won't matter which direction you go, your answer will match, but you better make sure you're doing something true. Okay, we good with that?
Mm-hmm.
That is the hardest it could get on the GED. Okay, that's as nasty as I got for this kind of a problem. Okay, ladies, do you guys have any questions about this?
No.
Cool. So we're going to build on this area and perimeter from definition. The biggest complaint the GED testing service had with us math teachers in trainings was they said, you guys teach area and perimeter and volume to your students, but you always teach them at a shallow level. And we never test at a shallow level. We always test at a higher depth of knowledge for these problems. You have got to take them deep through this. And so we're going to cover this deep. We're going to look at it by definition. We're going to look at it with formulas. We're going to look at it on what they call composite shapes, where it's all these funky shapes stuck together or holes in it. And what do you do? We're going to do all those things to make sure that we have that really deep understanding that we need. Okay. And y'all can see my daughter flitting in and out of the picture here. There she is. She'll be YouTube famous. Okay. So that's what we'll be covering in the weeks to come, because I want you guys to be like area and perimeter ninjas. Okay. Fair enough? Okay, awesome.
Yeah.
Thank you, ladies, for showing up. I so much love having students in class. It makes my day. And hopefully I'll see you next time.